One of the consequences, if vectors are proportional and we have 3 points that are distinct from one another, resulting from those vectors that are proportional, one of which is actually between the other. So the betweenness of points is also very important to identify which point is between the other. Generally, on our high school years, we're also using the formula in solving for whether which point is between the other. Because what we just need to do is to make sure that, say for example, a certain distance of, let's say, P and Q, and we have here also Q and R, and possibly you will have here P and R. We could only say, of course, we have 3 points here, P, Q, and R, one of which is between the other. If we could establish that, say for example, the distance between P and R is equal to the sum of the distance between P and Q and the distance between Q and R. Take note that P, Q, and R here are arbitrary. They can take any values. They can take any points or any illustration as well. If we could establish that one is the sum of the other, the common point between those sum of terms is actually the point in between the other. But this is what we've been doing during high school year as well. We're also going to use this here as well. But the point here is the distance is not the distance formula we used on previously. Okay, in the high school years, distance formula here is a formula we just discussed a while ago in this playlist. So that's the difference here. So say for example, for P and R, we know that it's R minus P, which will take the square root of the square of the components and the sum of the components. Okay, we will have an example for this illustration next video. The point here is this idea of the betweenness. Once we could establish that the sum of two distances is just equal to the other, the common point between those two distances with which are added is the point between them. Thank you very much for watching.